Okay, so let's continue this discussion on, we were talking about what are the benefits and drawbacks of LCA exercise. So let's here we'll look at an example. This is an example from California, which was in 1990s. 1990s LCA was, although the concept of LCA in terms of just the concept was also in very much infancy, like it was just started. So there was no ISO method. There was you may find some studies here and there, but not a detailed LCA study. So in 1990s, but California, they had a policy goal of reducing emissions of air pollution. So what they did, they encouraged the adoption of zero emission vehicles. So they wanted to have a zero emission vehicle where essentially they wanted to reduce around 2% of the fleet by 1998. In 1990s, they started with reducing a zero emission vehicle into like 2% of the fleet by the year 1998. So they wanted to have 2% of the cars in California to be zero emission cars by 1998, which will increase to 10% in 2003. So it's if you think about it, it sounds a very good goal, isn't it? So you want to have zero emission. Zero emission means it will reduce the air pollution. Great, but since there was no LCA thinking, which in many of the decisions that we make even today, we don't take this LCA thinking. That's the problem, and that's why the concept of this life cycle analysis into the systems approach, where you rather than having a like a narrow what we call silos approach, we go for a systems approach. So here these vehicles, this zero emission vehicles were battery powered. Now you are using batteries, and that too lead acid batteries. So lead acid batteries were used. Lead is a big environmental problem, which we already can know. That's why we got rid of lead from lead-based paint. That was, we are getting rid of lead from gasoline, from the petrol and the diesel. We want to get rid of lead from our electrical and electronic equipments, like all these laptops, TVs, and all. We don't want to have too much lead in there. And why? You already saw. We had I think in the second week in one of the module, we also looked at the health impact of some of these major contaminants. And the lead was one of them. So and this was using lead acid battery. So now you have the lead, you have the acid, and you are using this lead acid battery powered cars, so you need to charge them. So for charging, if you are using thermal power, so again you are using more and more energy. So these vehicles, although they were claimed to be zero emissions, but in the real terms they are not really zero emissions. You are not doing emissions from the vehicle, but you are already doing emissions in the form of manufacturing of these lead acid batteries. You are doing emissions in terms of all the energy that you are using to charge these batteries, to power these batteries. So it's so there was a study done later on by Lave et al. In 1995, and that they said that this policy would not achieve its intended goal. So they come up with that this policy will not achieve the goal. And so what were the problems? We talked about some of the problems already. So if you look at what were the problems, the problem was cars were fully powered by batteries. Now these batteries were using, the batteries are being used. So batteries of these types need to be recharged, as I said earlier. Now for recharging of the battery, like you recharge battery, you recharge your cell phone, you charge your mobile, or anything you use, you have to recharge, laptop, iPad, all that. You are plugging into your electrical socket. Now if that electrical socket is that electrical power that you are getting, especially if you are in India, most of the places we are getting thermal power. So if you are getting this thermal power, you already saw the water footprint of a thermal power. You already kind of have an idea of how much energy in terms of emissions of a thermal power plant. So the recharging happens with electricity. Electricity production has air emission problem. So so what we have done, although the car has zero emission, but the stuff that are going to make the car has a lot of emissions already. So we have what is it's very similar to what we are talking about earlier in terms of the problem shifting. We have shifted the problem to something else. So we did not really solve the problem. So, and at the time that we are talking about in early 90s, the batteries were lead acid batteries. So, heavy batteries for battery only power, the batteries was huge, large amounts of lead was needed. Now, this lead has to be procured to make this lead acid batteries. So, that will come from the mines. From the mines, if you think about from the mines, it will go to the like a smelting plant where they will get those lead out, and then it will go to the manufacturing, and all these processes will have lead emissions coming into the environment and other emissions associated with lead smelting and all. So, the large amount of lead is needed with significant manufacture and recycling emissions of lead. So, and the more lead released them, then without like a zero, more lead was releasing into the environment as opposed to other cars, so the non-zero emission vehicles. So, this whole exercise, although the policy, as the policy looks, it sounds really great, isn't it? You want to go for a zero emission car, but if you to achieve this zero emission car, the means that you are using, if that means are not environmental friendly, or if the means actually has bit higher environmental burden or environmental footprint as opposed to what is really happening with this normal gasoline power car, your purpose is defeated. So, that is what happened in this particular case. Although the goal was very like a novel, they wanted to have zero emission, but they could not achieve it because of although on a first look it looks like yes, it was great, zero emissions on the road, but emissions in the form of lead, emissions in the form of air pollution from the thermal power plants, or what kind of from the energy supply, so water footprint. So, if you do it, so what could have prevented this kind of decision? So, that is why in the world today, recently we were a few months back, we did a life cycle analysis 3-day short term course here, and one of the very senior professor who just was actually retired now, but he is around on campus. He just came back from California visiting his visiting his son, and he just came back, and there in California he mentioned that now most of these places in US and other places, as part of this pavement engineering or the pavement design, they are asking life cycle analysis data. They are asking the life cycle analysis done on those as part of their pavement design to see that what is the environmental footprint. So, these things are coming. Many of these World Bank funded project, any international funding agency giving funds these days, they want this life cycle analysis to be done, which is kind of a big brother of LCA. So, which is a big brother of EIA. So, we have been doing EIA, and EIA is mandatory for most of the projects. So, but LCA will become also mandatory from the years to come. So, what the LCA exercise does, it helps us to not make these kind of mistakes, where so we could have, LCA looks at in a more systems approach. Had we done an LCA on this California policy, we could have found that although you are having a zero emission vehicles, but for the zero emission vehicles you are going to use this lead acid battery. The lead acid battery will have this environmental footprint, and then you will be using energy to charge these batteries, and that for that matter you will have this much environmental footprint. So, in totality actually you are not really gaining anything. You are actually, in terms of the environmental footprint, you are going to be in the negative side, which was found out later in this particular case. So, that is why for any policy we have to, especially for the environmental policy, where we are trying to really have a environmental like a environmental benefit, we have to look at things in a more global scale rather than in a silos scale. So, an LCA study could have pointed this out, but it was not performed originally because it was not that popular at that particular time anyway. So, they could not do it. So, with that, let us look at what is the history of LCA. So, it was not done in 1990s in California. So, when it started, how the LCA, again it's very interesting. Anything you learn, you should try to have some background, like okay, when did it all started, who started this LCA exercise, how it has evolved over the years, because those things are always interesting to know, because it encourages your curiosity. It helps you to be more curious about the subject matter. So, life cycle cost analysis is a subset. Cost is a subset of LCA. Cost focused, big factor in infrastructure management, and we also do life cycle cost analysis. But initial LCA work was focused on energy, and that is what initial LCA work was focused on energy. And you believe it or not, the first LCA was done much before, even several years before I was born. So it was done by Coca-Cola, although in true sense we really cannot really call them an LCA exercise, because it was not an LCA exercise as we know it today. They did not use that ISO methodology. So if somebody is very strict, they may say that that was not really an LCA exercise. But for that matter, in terms of in terms of the first multi-criteria study that was done, that was in 1969. It was done by Coca-Cola company. And why they wanted to do this LCA study? They wanted to have a choice between the glass or the plastic bottle, whether we should go for a glass bottle or the plastic bottle for the container. As if you are old enough, you may have seen that we used to use even for the smaller volume, we still use today. We may not use Coca-Cola, may not be that much, but for thumbs up and other things, we do see maybe Coca-Cola is also there. I don't drink those soda too much, so I don't really know, but I have to. I do see those small bottles. So for 200 ml or 250 ml, those glass bottles are still available for some of these soft drinks. So, but earlier we also used to have like a 1 liter bottle, 1 liter of a glass bottle, which you don't see anymore right now, but it used to be earlier. And before that, even all the bottles used to be the glass bottles. So these plastic bottles came later, and then we also have these aluminum cans now. Aluminum cans are also used in soda industry, in the soft drinks industry. So Coca-Cola industry in 1969, they wanted to know whether they should go from glass to plastic, because they were using glass. What is the benefit of using glass? You can use it again and again. You can wash it and use it. But when you wash it, of course, you have a energy input, you have a detergent input, you have to clean it up, and then you have to bring it to the bottling plant again to wash it, and then bottle it and send it back again. So there is a additional transportation also involved with that. So that's there is a it's in terms of the container for the choice between glass and plastic container. So they wanted to actually have a plastic bottle manufacturing within their plant. So that was their choice, whether they can have choice. And they also looked at end of life option, whether they could go for recycling or it should be a one way, use it and throw it. 1969, even the plastic recycling was not that much very popular. But they did find that if they go for recycling, the plastic bottle was best, contrary to expectation. Why the plastic bottle was best? They assumed that it will be recycled, and but they were only looking from the cost perspective, from the economic perspective, and from looking at how much it will in the transportation cost, because the glass is heavy. So if it's anything heavy, it will require more like energy and things to transfer. But this study was never published. So, and it was never published. So we don't really know. It was an internal exercise by Coca-Cola company. So, but that was kind of first multi-criteria analysis, but it's something similar to LCA. So if you want to say that the first kind of multi-criteria study similar to LCA was done in 1969, which was much earlier. So question of validity, of course, that occurred, that whether it's a valid exercise or not, but but then kind of that led to, because the Coca-Cola came up with this answer, which kind of the scientific community was saying that it looks like something wrong here, because it kind of goes against what the popular belief is, that although the glass should be better than the plastic bottle. So that led to the call by scientific community to have a standardization procedure for this kind of a test. So we should have a standard method. So we can say that everybody has to go by that standard method. Then we can compare. The comparison will be fair in terms of the different options. So if you look at how this LCA was developed, so this is kind of a history of this LCA life cycle analysis thing. So 1969, that's the first we just talked about. Coca-Cola company, the resource and environmental profile analysis, that's what they called it, Coca-Cola USA, REPA. This was done in 1969. From 1969 until 1984, that's almost how much, 15 years, there was not much activity on LCA front. Not much work was done in that 15 years, but in 1984, in Switzerland, this environmental report on packaging So that's the environmental report on packaging. This packaging organization, they come up with this environmental report. So that came up in 1984. That's where so in a real sense, you can say the LCA that we know as of today is kind of started in 1984. So that's what you see over here. So this packaging industry in Switzerland. So that's how the EcoInvent organization is in Switzerland, if you remember, that we talked about earlier. Then in 1991, CTEC got involved. CTEC is the Society of Environmental Toxicology and Chemistry. It's a very big organization. It's an international organization. Basically, it's like a professionals organization. It runs a lot of courses, workshop. You may be familiar with CTEC. If you're not, you just Google CTEC, and then you will find a lot of information on that. So CTEC got involved, which is a lot of professors are a member of CTEC. A lot of environmental professionals are member of CTEC. So they got involved, and they had a first workshop in 1991 regarding LCA. So that's LCA started getting popular. Then around the same time in 92-93, the first European guidelines on eco-labeling come. Eco-labeling is when you are labeling a product to be which is a green product. So which we will talk about that later on as well. We'll talk about some of the design for environment, and when we put a green dot, it's not a green dot. A green dot, like if you in India, when you buy any food product, if it's a green dot, it's a vegetarian, and the red dot is non-vegetarian. But that doesn't mean green means it's a environmental friendly stuff. Although vegetarianism is environmental friendly than non-vegetarian, which we saw that from that water footprint. If you remember that slide from water footprint, the vegetarian diets are actually has a lower water footprint. So that way, yes, the green dot does say that it's a environmental friendly. But for just that was just a joke. For this. In terms of environmental profile, if there is a green label, there is an eco label. So European guideline, we don't have a green label in India right now. We have a proposal to have a green label like that in India too. Some countries already have some green label, and that for the green label you have to do some LCA exercise and show that your product is really green. So the first European guideline that came on eco labeling came in 92-93. 1997, this life cycle assessment journal came. It's the International Journal of Life Cycle Assessment, and it's a very popular journal now. And it's a pretty good impact factor. It's not that easy to publish in this journal in terms of LCA, but this is there are other journals also who publish LCA papers, but this is a kind of the oldest journal in terms of just dedicated to life cycle analysis. So 97 it came at the same time. Between 97 and 2000, this ISO standards were developed, and we'll talk about ISO standards very soon in I think next few slides. So ISO standards came. ISO 14040 is the standards for life cycle analysis, and I will go through this ISO standard because that's very important as part of the methodology for LCA. So that's ISO standard came between those 3-4 years, and in between in the year 2000 we have this EcoInvent Center. EcoInvent, if you remember, again, it's an organization based in Switzerland, and they are basically the biggest database center in terms of life cycle analysis. All those LCI inventory data that we need, EcoInvent has it. I should not say EcoInvent has it. EcoInvent tries to procure that. So they have data from Western European countries. Right now, they are trying to collect data from South Asian countries. They are doing some projects in India. They are doing some projects in Bangladesh, also in Africa. So they are trying to develop some databases from different sources. And since they are collecting all this data, they do sell those data. Many times this data is not available for free. But as I said earlier, as an Indian academic, Indian student, you can get this data for a free access, but just only for academic purposes if you approach them. So going to EcoInvent, which was a good like right now we use EcoInvent database quite a bit in doing the LCA exercise. So 2002, and you will see some of these again in some of the case study when we come back in terms of how we use EcoInvent. So 2002, UNEP, United Nations Environmental Program, they also got involved as LCA. Now there is a UNEP CTAC life cycle initiative, which is a part of so even this conference that I was mentioning to you, that Indian Life Cycle Management Conference, which happens every year, FICCI organizes that. So there UNEP people were there, some CTAC people were there. This life cycle initiative, this was kind of part of the organization team. So UNEP life cycle initiative, CTAC, they all came together rather than having individual effort. So why not let's do a team effort, and then things gets much better. So that's how these things came together, and then now this is kind of the guiding force behind this life cycle in the globe, I would say. So UNEP life cycle initiative, where some of the European countries are also involved, Western European countries, CTAC, which has presence all over the world. So this is the guiding principle behind life cycle analysis today. Then we had European LCA platform came, EP-LCA in 2007. ILSD handbook, which is again European document, like how to do life cycle analysis. So that's a handbook, and this handbook is available for free. You can download that. Social LCA guideline, which is how to do social LCA, which is not that easy to do because the social norms changes a lot from place to place. Environmental emissions don't. Say if you have the same process, whether you are using that process in India or whether that you are using the process in Australia or in the US or say in Western European countries, if it's the same process, similar input, you will have similar emissions coming out. But in terms of the social, whatever things which are socially acceptable in Indian context may not be acceptable in European context. So that's or in American context, and vice versa too. So that's why social LCA gets a little bit complex, and it's more qualitative than quantitative. It's very difficult to put a quantitative number. So it's a important, it's a nice document, but it does get confusing sometimes, like how to do this social LCA. And still, we will cover that a little bit in this class, but I would encourage you to kind of look at that document more in detail if you are interested in that area. So this is how this LCA exercise is going on right now, where we have this different, this is how like a development of LCA over a course of last, I would say mostly 3 decades, 3 and slightly more, 3.5 decades. So that's because the 1969 one was kind of a standalone work and nothing happened for next 15 years. So this is kind of history of LCA. So let's look at, so after that, let's look at this ISO framework, because as I said, the ISO framework, which came in between 1997 and 2000, when the first version of this ISO framework came, this becomes the guiding principle now of how to do an LCA exercise. Again, if you remember, for any environmental analysis, we have a standard method. Remember, I told you that for the water, wastewater, or air samples, we use that as standard methods. You walk into any environmental lab, you will have that blue colored or slightly like a these days, I think the newer version has a light green color cover. So you see a standard method book, which will be there in any good environmental lab will have it. So similarly, when you go for this when you go for this LCA exercise, you need to have a method. So that when you do LCA here in India, somebody doing LCA over in US or other places, if you want to compare the different work, they should be done in like a similar steps. So this ISO framework tells us what are those similar steps, and we kind of talked about that already. So it should not take that much of time, but I will go through this ISO framework, and it does get boring a little bit. So I apologize for that, but I will try to keep it as interesting as possible, because any rules, guidelines, they tend to get a little bit of dry. It's not that it's a dry stuff, so things does get boring. So here, if in terms of the ISO framework, again we have 4 major areas. The number 1 is the goal and scope definition. So that's what you need to, we already talked about, we did that for the bulb. If you remember, for the bulb exercise, we had a goal, we had a scope definition for the bulb. If you don't remember, go back and watch that video again. So that's as per ISO 14044. And ISO document is the older version. ISO documents are not available for free actually. You have to have a subscription of that. So if your library has a subscription to ISO document, you may be able to get it through your library. If your library doesn't have a subscription to ISO document, if you Google this ISO LCA methodology for ISO, like ISO framework for LCA methodology, you'd get a older version. The 2006 version is available for free. There is a newer version out there now, but 2006 version, older version, you can. When I was googling it this morning, I could find it. So it's available on the Google. So, but like the newer version, you need to actually pay. It's around 25 euros or something like that. So there are four main components which we already talked about: goal and scope definition, life cycle inventory, we already looked at that, life cycle impact assessment, we looked at that as well, and the interpretation, where we went from midpoint indicator to endpoint indicator to the single score. So that was in terms of their the interpretation. You see on this particular chart, if you look at carefully, there are for these, I have these arrows pointing both sides. So what are these means? Or here also at the bottom, when we talk about the application, here it means that it's an iterative process. So you learn and then you change. So you want to have a goal and a scope, where when you interpret and then you find out that, okay, this is not actually you wanted to study, you wanted to study something else, then you go and change your goal and scope. When you look at your life cycle inventory, if some of the data is not available, what you will do? If the data is not available, it's not available. So rather than using, say, bad data, you may have to kind of tweak your goal and scope, tweak your interpretation accordingly. Same thing with the impact assessment. So it's an iterative process. The collected data may lead to the modification of the scope. So once, depending on the data that is collected, it can be it can lead to the modification, and the goal itself could also be revised. So you can revise the goal based on what the data is available, what kind of so this is there is a flexibility in the system in terms of how you interpret that. So goal is what for. Now some of the slides that you will see from now this point onwards are essentially coming directly from the ISO which the ISO document. So especially the bottom part that you see over here, it's essentially a copy and paste from the ISO document. So the reason for putting it over here is just to give you some example. So that's why it's a goal. What is the goal? Must clearly define. The goal is for what we are going to do and what for we are going to do. So it should clearly define the object. So what is the object? What is the objective of doing this exercise? What are the reason why, and who is the intended, what is the intended application, who is the audience, what we will do with this exercise. For example, from this ISO standard 14040, we have, if we want to identify opportunities to improve the environmental performance of products at various points in their life cycle. Now what does that mean? Say if you have a product, for example, if you have a like a mobile phone, so in that mobile phone you want to use this, you want to do an LCA of this mobile phone itself. So there are different components which is present to this, there are different stuff in here. So you want to find out what are the different makes, what is the different unit processes associated with that, and we'll talk about unit processes in a little while, probably in the next module. So there like for the different unit processes, which unit process has higher environmental footprint. So that's what you want to look at, the environmental performance of product at various points in their life cycle. So does it uses too much of a battery? Like many times we see these mobile phones, the battery works okay for maybe 1 year, and after that the battery starts discharging very quickly. Maybe we load them up with too many apps. That may be the reason. I am not a electronics engineer, I don't know what is the reason for that. But okay, so in terms of whether the battery is not efficient or something, like can we improve this product? So we look at the whole unit processes associated with making of this cell phone, of this mobile phone, this smartphone, and then for the individual unit process we look at their environmental footprint. So the one which shows very high environmental footprint relative to others, we focus on that particular process, and then we talk to our electronics engineer, electrical engineer to say, okay, is there a way to reduce the environmental footprint of that? So that's what the first bullet of the example that you see over is trying to say, where you're trying identifying the opportunities to improve the environmental performance of product at various points in their life cycle. So that's that could be one goal. The other goal could be that you want to talk to the decision makers in the industry or the government or the NGOs for planning, priority setting, product or process design or redesign. Similar concept what you just said. You look at your product and you find that the environmental footprint is higher, then you talk to government, you try to impress upon government to have a better policy so that the companies are encouraged, they get some incentive to do it a environmental more better product. Now even you can do selection of relevant indicators for environmental performance, like you look at the measurement technique, if the measurement those kind of stuff, and also for marketing, like if you want to do a, if you come up with, say, for the two different, again I kind of use a lot of examples from the electronic industry, because that's everybody carries a mobile phone, or not, like most of us, most of the middle class these days have a smartphone. So at least that's what so say if you have two similar smartphone with similar performance, similar price and all that, so you can do an environment LCA exercise on those two models, and then you can say that you can compare, and then you can say my product is better than the other product, and that kind of gives you an incentive in terms of the marketing. So those things can be done as well. So we will continue looking at this ISO standard, kind of go more in terms of this ISO framework. We just looked at the first part. So in this next module, we'll continue looking at the other aspects of this ISO framework. So ISO, as I said, it's a method which we use to do LCA, and it's a standard method, so that throughout the world globally, people follow the same methodology to do this exercise, so that the results could be compared. So let's wrap this module right now, and then we'll go to the next module where we kind of continue with this ISO framework. Thank you.